Hello, welcome to the video of data structures and algorithm. In this video, I am going to have an introduction about data structures and algorithm and big O notation. So, I will be releasing a playlist on the data structures and algorithm. Different data structures I will be covering in this one, and the implementation will be done by using C++ syntax. So, let us go to the video now. What is a data structure? A data structure is a way to store and organize the data in the memory. As a simple definition, you can take this so that it can be used efficiently. So, the definition of the data structure is a way to store and organize the data in the memory so that it can be used very efficiently. So, if you look at the data can be stored, and you can perform two operations on that. One is searching operation and the other one is going to be modify operations. Okay. Having understood what is a data structure by the definition, let us take an example of library book racks. In a library, book is arranged in alphabetical order. Whenever you want to search for a name starting with A, we need to go to A row and then take the book. So, it can also be arranged in category wise. Like for example, you can categorize a book like sports books or mathematical books, or you can say biological books, like that. So, based on the category, you can go to the particular rack and then search for a book and then take it. So, books can be arranged in alphabetical order. So, why do you want to arrange in an alphabetical order? It is easy for searching. So, you want to do some operation on that one. So, you want to search a particular book. So, that is why we are arranging in an order. Books can be searched and it can also be rearranged. Rearranged in the sense like you can say alphabetical order. Within alphabetical order, you can see that you can categorize that within the alphabetical order. So, similar to this, data can also be arranged, it can be stored, it can be searched, and it can be rearranged. For doing this, we need to understand data structures. There are different data structures which we need to learn. Now, before going to that, let us see what is a data structure, and let us go for what is an algorithm, and we will introduce what is big O notation, and after getting introduced to the big O notation, we will go to the particular data structure and learn about each and every data structure. So, if you look at the data structure, these data structures are used in Facebook, it is used in Twitter, it is used in Instagram. Even when you are searching in Google, for example, if you type a word called as object, automatically you can see that object oriented programming concept, object oriented concepts in C++, like that. So, this is happening because of the data structure. The data is arranged in the data structure. That is the reason that this search is happening like this. Next, we go to algorithm. In a basic term, an algorithm is a set of well defined steps or rules that you need to follow to obtain a predefined result. For instance, when we talk about algorithm in computer programming, we already have our inputs. We know what is an expected output. So, we are going to see about algorithm in data structure. So, here we have an output which is predefined output which is required, and there are some inputs here. So, here we write some set of rules to take the inputs from this inputs and then give the predetermined results. So that's why we say an algorithm is a set of well defined steps or rules that you need to follow to obtain the predefined result. Now, having understood what is data structure and algorithm, now let us go for big O notation. What is big O notation? Big O notation is basically to calculate efficiency or calculate the power of data structure to solve a problem. If you have a problem and you have implemented a data structure for solving the problem, is that particular data structure, whatever you have whatever you have used to implement that problem, implement the solution, is that effective? How do you find that? We have different data structures. We are going to see about what are the different data structures in the upcoming videos. Which one to choose to implement to solve a particular problem? We need to have a method to calculate the efficiency of a particular big data, data structure. This method is basically called as big O notation. So we have already seen about the following things in the previous slides, like data is can be stored, it can be searched, it can be modified. So now what I am going to do is I am going to split this modify into insert and delete. So now if you look at this data, how the data is stored, how we search the data, how do you insert the data and how do you delete the data. You see store, search, insert, delete, all these 4 parameters are on the data here. So now basically store, search, insert and delete are the parameters. Using these parameters we need to create a report card. For a different data structure, using these parameters we can create a report card. So based on the report card we can select which data structure can be used for a particular implementation. So let us go detailed into this big O notation. Now here is how it goes. When you have n data, that means if you have 10 data or 20 data, how many operations you need to perform to store the data? How many operations, if you have n data, how many operations you need to perform to search? In n data, when you have n data, how many operations you need to perform to do insert and delete? Okay, so this is what we are going to see how it is going to happen in big notation here, big O notation. For example, when you are calculating, we have 4 results such as 10 operations are required, 50 operations are required, 1000 operations are required or 10,000 operations are required for searching. If you have 4 results, then what we need to do is we need to take the maximum. So we have to take 10,000 operations are required to perform the search operations. Okay, so if you have 4, for example, assume that you have 10 values or 5 values you have. If I want to search for the first value, then it is only one operation is required. Within one cycle itself you will be in a position to do, you will be in a position to search for that first value. But if I want to search for the 5th value, you need to search the first one, second one, third one, fourth one, then only you come to the data which you wanted to search. So you need to have 5 operations. When you want to search 5th one, you need to have only one operation, you need to search the first one. So if you are having such number of operations, various number of operations, you need to take the maximum one. That is what is mentioned here. So if you get 4 results, 10 operations, 50 operations and 10,000 1000 operations and 10,000 operation, you need to take 10,000 operation as a result for the parameter. What is big O here? If you write a function, its complexity is notated as O of 4. Okay, basically it has been read as O of 4 only. O within brackets you have 4. Meaning executing the function we need to have 4 operations. For example, there are 4 searches. There is a search operation. We need to do 4 operations to do a particular search operation. This is also called as time complexity of a function. This is what is called as big O. Why we cannot calculate the time complexity with the help of the time taken by a function or a function to execute? The answer is, suppose assume that you have a function. If you execute the same function in a supercomputer and if you are executing the same function in a laptop, both will differ. Supercomputer will execute the function faster. When it comes to laptop, it will be it will take more time than the supercomputer. So that is the reason that to generalize the complexity of a function, we use big O notation. So based on that big O notation, we have 6 difficulty levels. Like for example, if you have 1 operations, if I want to do a search or if I want to do store or if I want to do insert or if I want to do modify, okay. So if you, for every operation it takes only one operation. For executing a function you require only one operation. That is going to be the best one, and you have different other things like operations of log n, operations of n, operations of n log n, and operations n square, and operations 2 power n. So here operations of 1 is going to be the best, and operations 2 power n is going to be the worst. Let us go more detail about these 6 notations. Now considering the best one, O of 1. For example, if we say O of 1, or which means that any number of data, how much ever data is available, only one operation is required to store. It is required to search, or only one operation is required to insert, or one operation is required for delete. So basically the graph is going to be like this: the number of data in the x-axis and number of operations in the y-axis. So if I have two data, the number of operations is going to be 1 only, and if I have 4 data also, the number of data is going to be, number of operations is going to be 1. So that is what is the O of 1 big notation, big O notation. Second one is O of log n. In this, if the data increases, the operations will increase sharply initially and becomes constant later. Like it will increase very sharply and later on it becomes a constant value. That is what is O of log n. O of n. O of n is nothing but when the data increases, the operations will increase linearly. So if you look at this one, 1 data, 1 operation, 2 data, 2 operation, 3 data, 3 operations. Similarly, you have fourth one, which is O of n log n. If in this the data increases, the operations will increase slowly initially and then later on linearly it will increase. So slowly it will increase in the initial stages and later on it will come to the linear increase. Then you have the fifth one is O of n square. In this, If the data increases, the operations will increase sharply as n square. And the sixth one is also similar to that. It is O of 2 power n. If the data increases, the operations will increase sharply as 2 power n here. So these are all the 6 notations, big O notations, which we will be using it in our data structures to find out which is going to be the best data structures to solve a particular problem. Okay. So for example, for a big O notation for each and every parameter, in case store and insert are important parameters, then both O of 1, if both are going to be O of 1, then that is going to be the best one. For example, if you have for a particular function to execute it, for a particular operations to, for a particular function to execute it, you have for storing it requires O of 1, for searching it is O of n, for insert it is O of 1, and delete is O of n square. For n number of operations you perform the same, you get the same parameter here. This is for one data structure, and in another data structure if you have a different value, and when you want to compare these two data structures, if you are going to take store is important and insert is important for a particular logic, for a particular problem, then this is going to be the best data structure, which has O of 1 and insert is also O of 1. Okay. So basically this is going to be the big O notation. This is an introduction to big O notation. We will see how this can be implemented or it can be used to see the data structure efficiency by taking an example. Okay. So with this video is going to get completed. We have seen about what is a data structure, what is an algorithm, and we also got introduced to big O notation. The actual implementation we will see about how this big O notation is used to calculate the efficiency, and how you are going to implement the data structure, and how are you going to write the algorithm for doing the data structure in the upcoming videos.